Hey guys, today what we're going to be looking at is how to solve systems of equations using elimination. So let's go ahead and look at this problem. On this one, I need to solve for the point where these two lines intersect, and we're going to do that by using elimination. So the first thing I'm going to do is I'm going to look at these two equations, and I want to make sure my x's, my y's, my equal sign, and my constants are lined up. And then the next thing what I want to do is I want to see, is there anything I can multiply them in order to get a same coefficient for either my x's or my y's. So right now I want to focus on my x's and say, what do I have to multiply them both by in order for them to eliminate? So if I multiply the top equation by 3, and the bottom equation by 2, you see that I'll get the least common multiple between 2 and 3, which is 6. This will give me then positive 6x minus 9y is equal to 21. Then on the denominator, I'd have negative 6x plus 8y is equal to negative 16. Now what I'm going to do is I always like adding up these equations. So when I add these, my x's are going to cancel, and then I'm going to do negative 9y plus 8y is negative y is equal to 21 plus negative 16 is positive 5. And then if I just divide both sides by negative 1, I'm going to get y equals negative 5. Now what I know what y equals, I go back and I look at my original two equations, and I want to plug in negative 5 for one of these equations. So it doesn't matter if you choose the top or the bottom. I'm going to choose the top, so I'm going to have 2x minus 3, and instead of that y, we just solved for it, I know it's negative 5, and that equals positive 7. This will then give me 2x plus 15 is equal to 7, and then I'm going to minus 15 on both sides, and that'll give me 2x is equal to negative 8. Once I divide both sides by 2, I'm going to get x is equal to negative 4. Now remember, this is an ordered pair, so I need to write the answer as negative 4, comma, negative 5. And this is the point where the two lines intersect. Alright, so let's go ahead and look at this one now. This one looks a tad tricky because it has decimals. The first thing what I want to do is, I'm not a big fan of decimals. So if you notice, if you multiply everything by 10, just move the decimal over one spot to the right. So I could have two new equations of 4x plus 5y is equal to 25. And then I can also have 12x minus 35y is equal to 25. Now I have two choices. I can multiply the top one by 7 in order to get the y's to cancel, or I can multiply the top one by negative 3. I'm actually going to choose to multiply it by negative 3, the top one, because I want to get rid of the x's. So in red, my top equation will change to negative 12x. Sorry, let me fix that. So it'll change to negative 12x minus 15y is equal to negative 75. And now when I combine these, my x's are going to cancel. I'm going to have negative 50, negative 50y, and it's going to be equal to negative 50. When I divide both sides by negative 50, I'm going to get y is equal to 1. Now that I know y is 1, I'm going to plug it back into one of my two original equations. You could use the decimals, or you could use the ones that you solved to the right over here. I'm going to choose this one right here. So since I know y equals 1, I'm going to have 4x is plus 5y, and I'm going to plug in 1 for y, equals 25. I'm going to then subtract 5 on both sides, because 5 times 1 is just 5, to get 4x is equal to 20. I'm going to divide both sides by 4 to get x equals 5. So I'm going to have an ordered pair of 5, 1. Alright, so let's go ahead now and look at the next one. Here what I'm going to do is I notice that My least common multiple, I'm going to focus on the a's right here. My least common multiple is 15. And I need to make one positive and one negative. So what I'm going to do is multiply this top one by -5 and this bottom one here by 3. This makes it so the coefficient of the a's will be, one will be 15 and one will be -15. So the top one's going to be -15a plus 20b is equal to 20. On the denominator, I'm going to have, on the bottom equation, I'm going to have 15a minus 21b is equal to -27. So these are going to cancel. I'm going to have -b is equal to -7. When I divide both sides by -1, I'm going to have b equals 7. So now that I know what b equals, what I'm going to do is plug it back into one of these original equations. And so that will be 3a minus 4 times 7 is equal to -4. This will give me 3a minus 28 is equal to -4. And when I add 28 on both sides, I'm going to have 3a is equal to 24, which means when I divide both sides by 3, I'm going to get a is equal to 8, which means the point where these two lines intersect will be 8, 7. And I know it's 8, 7 and not 7, 8. It's because it always goes in A, B, C order unless it gives you context for the problem. All right, so let's go ahead and look at the last one right here. On this one, what we're going to do is I need to get a common denominator, a least common multiple. So I look at the 3 and the 11, I look at the 6 and the 9, and I think I can get it closer if I do 6 and 9. So the least common multiple between those two is 18. I'm going to multiply the top one by -3 and the positive one by +2, the bottom one by +2, and I will get then -9c minus 18d is equal to +21. On the denominator, I'm going to get 22c plus 18d is equal to -60. So then when I add these then, if I have -9 plus 22, that'll be 13c. My d's are going to cancel, and that is going to equal then -39. If I divide both sides by 13, I'm going to get c is equal to -3. Now that I know what c equals, I can figure out what d equals by plugging in that -3 every time I see a c. So let's look at my two original equations, and you get to choose whatever one it looks easier to plug in. And it doesn't really matter, I'm just going to plug it in the top one. So it's going to be 3 times -3 plus 6d equals -7. This will give me -9 plus 6d equals -7. And I'm going to add 9 on both sides in order to get 6d is equal to -7. 6d is equal to +2. So when I divide both sides by 6, I'm going to get d equals 1/3. So the point where these intersect is -3, 1/3. All right, guys, if you have any questions on any of these, please feel free to email me or your teacher.